Artificial intelligence is revolutionizing the semiconductor industry at breakneck speed, with chips now consuming kilowatts of power and operating at previously unimaginable frequencies. Behind every GPU and memory chip powering ChatGPT and other AI engines lies a critical challenge. How do you test devices this complex to ensure that they work? Today, we explored this hidden cornerstone of the AI revolution with Mike Slessor, CEO of FormFactor. Mike, thanks for taking the time to discuss the state of semiconductor testing today.
Thanks, Paul. Great to be here.
Mike, AI is obviously driving innovation in chip design, and that has implications on everything that surrounds that process, including testing. Can you just kind of talk about what you've seen in terms of changes and evolution here in a rapid cycle of development?
Well, as you know, it is probably the most rapid cycle of development and technical advancement in my 25 odd years in the semiconductor industry. And, if we look at the semiconductor content powering generative AI, powering the large language models like ChatGPT and Microsoft Copilot, there are several basic semiconductor components. One's a GPU or graphical processing unit, together packaged with a bunch of memory, a specialized DRAM called the high bandwidth memory. And those two silicon elements are really stretching and advancing the capability of both the logic and foundry industry in the case of the GPU and the memory industry in the case of the HBM. It all kind of, though, revolves around power and speed. And by power, the electrical power used and generated by these devices is just astounding, right? You've got GPUs, individual GPUs, roughly an inch by an inch, that are going to be consuming about a kilowatt of power. The HBM arrayed around these GPUs that does the high speed data storage and transactions. These are speeds 10 gigabits per second, 12 gigabits per second, previously unheard of in the memory industry. But when you think about the computation that has to happen in these generative AI assemblies, that power and that speed is central to the functioning of these chips. And of course, if you're going to test them to work in the intended mode, high speed and high power are something that all of the test products, things like our probe cards, things like the testers, must be able to handle. So we now have probe cards that have individual probes that carry close to 3 amps of current to get all of this power in and out of the chip. These probes that operate at RF frequencies, even in memory tests, so that the chip can operate at these very high speeds. And our customers know that they're going to work in the intended application once they're all assembled together.
And you talk about the testing requirements for things like GPUs, and you just described a little bit about how you're addressing that. I assume as a company, it's really been both challenging and rewarding to try to meet that rapid, set of new requirements that the industry is asking for in real time.
And that's the essence. If we go back to the collaboration model, that's the essence of getting there quickly, is getting very clear requirements from our customers, understanding what they need to test their next generation devices, and then making sure that we're able to deliver it. It is challenging for sure. It's also rewarding. If you look at how our AI-driven business has grown over the last year, it's pretty spectacular. Well, some of the classical applications like mobile phones and PCs have been really not growing. They've been relatively stable, but not growing. All of FormFactor's growth has been driven by succeeding in delivering compelling products to customers in these high power, high speed generative AI applications, whether it be GPUs or high bandwidth memory or switches for co-packaged optics as well.
So I know you're in the midst of just trying to keep up with the ever-changing things that are going on in the business, but how do you see kind of architecture evolving, and how does that have implications for just being ready to ramp up on the next innovation you need to have to meet the needs of the industry?
Yeah. Well, it's the essence of being a supplier in the semiconductor industry, right? The rapid evolution of technical requirements, of operational requirements, of volumes, all of those things are a staple of the industry, and that's nothing new. It's just the speed and complexity has accelerated here with the requirements associated with generative AI.
Mike Slessor, CEO of Form Factor, thanks for joining us. As generative AI compresses years of innovation into months, the semiconductor testing industry has become the unsung hero, ensuring every chip meets its extraordinary specifications. Through strategic collaboration and deep customer partnerships, FormFactor continues to bridge the gap between cutting-edge silicon and the test equipment that validates it. In this new era where a single GPU consumes a kilowatt of power, success isn't just about having the right technology, it's about working together to solve the industry's most complex challenges. I'm Paul Swangard for Mission Central. See you next time.